Yeah, thanks, Jim. Thanks, everybody, for coming. I know Matthias and I, I'm going to try not to break any of the expensive equipment. So Matthias and I are really excited to talk about this. He and I have worked together now for, about 2.5 years. And this text mining stuff is very interesting. He definitely knows a lot more than I do, which is why I have the easy, short part in the beginning, and Matthias has the harder, more challenging, more interesting part probably in the second half. So what we're going to do is sort of organize our talk in this first part into two mini parts. And the first of the mini parts will be me, and I'll just be explaining kind of with an exemplar data set what sorts of things you can do with text mining. And the goal of this is really just to give you a sense for the kinds of statistical results that you might be able to get out of this. And then Matthias will, and that's with one data set, and then Matthias will take a second data set and go through some of the same stuff, but actually show you with R how all that works. So that's our plan. And I think he and I are both fine with you all asking questions as we go along. So please feel free to do that. So without further ado, I guess I don't have to point at it. But see, I'm just old, so I pointed at it. So obviously not everybody will agree with this statement. But as a statistician, and Deming was a famous, very famous statistician. Then I feel like I think we both feel sort of obligated to say, hey, data is important. And one thing I would start out with too, to begin with, is I don't think either of us views data mining or text mining, in this case, as a replacement for qualitative research. A lot of you all are probably coming from a qualitative background. And I am a statistician who very much values qualitative research. So although I don't do a lot of it myself, I definitely don't see it as lesser or that this text mining is somehow going to be replacing qualitative. In fact, I see them as very complementary. And I'll tell you a little bit about how that, sort of how I got interested in that and how that feeds into this qualitative-quantitative synergy that I think exists. So the first question is, why is text mining important? And if any of you have done qualitative research, then you're very familiar with the notion of coding, textual data, interviews, observations, whatever, and the amount of time and energy that goes into sort of that qualitative coding. And text mining is a way that is a tool, at least in our minds, I think, is a tool that might be helpful in aiding you in that regard. In other words, not just something to not at all something to replace the qualitative coding, but as a way to sort of validate the coding, or the coding can validate the statistical, the quantitative stuff. And so text mining is going to be very useful for identifying patterns in your textual data that you might not have expected, or that you might not be able to see, given lots and lots of text that you have to go through. And so this notion of hidden data in the text really just means, are there patterns in there, patterns of word usage is really what I'm talking about, so I should be more specific. I'm talking about patterns of word usage that are potentially interesting, that tell you something important about the text that you're working with. And we're going to look primarily today at descriptive statistics, but I'm hopeful that you'll see how, even with descriptive statistics like frequency counts, correlations, and things like that you can get a lot of really cool and useful information. So my interest in this originally came from working with colleagues who had short answer questions on surveys. So if you all have ever, we've all done surveys, you can fill it out, and often there'll be a question like that asks you to write a paragraph or something like that. And so I had colleagues who were interested in trying to glean something from that and maybe relate what people wrote in their open-ended response back to what they said on a survey. And so we started playing with this text mining to look for patterns in those open-ended surveys. And again, as a way to merge qualitative and quantitative work. Since then, I've been fortunate enough to work with another colleague who has focus group data. And she has focus group data from college students, and they're talking about specific topics. And so we're using data or text mining to try to pull out underlying patterns in the focus group transcripts. So very different kind of data, lots and lots of text, the people talking in the focus groups. But again, a way to sort of pull out, when people talk about issue A, say grades,
what are other words that tend to come up when they talk about their grades? Happy, sad, whatever. So that's another project, and Matthias can talk about other things that he's done, and he'll show you some examples of that. So, okay, so that's enough about that. So the data set that we're going to be looking at, this first part, is a data set that comes with the R software package. And if you're not familiar with R is an open source, meaning it's freely available. People add functions to it all the time. Statistical software package. And you can be downloaded onto any machine, any kind of computer you've got. All of the functionality that it is available is free for you to use. And so that's the real advantage of R. The disadvantage is it's a programming language and it can be a real pain in the neck to use. And some of my students are here and they can assure you that is in fact the case, even for people that use R a lot. So it does do a lot of cool stuff and it's free. So there's a data set that's available with R called the Jane Austen data, and it's essentially the text of her 6 novels. And we're going to be looking at that data today. It's an example that's very nice to use because the data is clean, it's been cleaned up, and it's pretty straightforward. Most of us have read some of Jane Austen. I'm sure many of you all have read all of Jane Austen, and so you'll be familiar with her work. We're going to be using something called the Tidy framework. I don't think that's so germane to our discussion, at least right now, but I do want you to be aware that if you're reading about R and text mining in R, there are different ways to do it. The Tidy framework is the one that we're using, and the reason is that it tends to be easier than some other types of R syntax. So that's why we picked it. But if you go off, and I hope you will, go off and investigate stuff on your own, you're going to find that there's other ways to look at it. So we're going to talk about the 6 novels published by Jane Austen, and as I said, the data set's available. It's been cleaned up, and I really want us to focus on the statistical things that we can learn about the novels, and at least at this point, not so much on the nitty-gritty, but we will get to that. So essentially then, the data set, if you want to think about data, and I'll show you kind of a little tiny snapshot of what the data look like. Essentially, the data are going to be the lines of text from Jane Austen's novels, right? So each line of text, if you think about reading a book, each line is going to be a line of data to start with. That's how the data is input. And so if you were to look at it, it would look like that. I asked R to show me the very first 10 lines of data, and that's it. And so you see the title of the novel, then you see a blank line where there's nothing, and you see the by Jane Austen. So that's not how we want the data to be in the end when we do stuff with it, but that's how it starts out. And oftentimes with textual data, that's what it's going to be like. It's going to be a book or an interview transcript or something like that that's just lines of words. You can see the number of lines in each of the texts. So, the Mansfield Park is, well, no, I guess Emma's the longest. Mansfield Park is pretty close, and then you see like Northanger Abbey, it's much shorter, so obviously that's a lot of lines of data. If you think about those of you who have worked with data, to think about data sets that are that many lines, that's a lot of information. So the computer is going to be, I think, very helpful. The reason I wanted to show this is to show the computer can be very helpful in parsing through all that information. Imagine trying to do that. Well, I guess you probably have, but I haven't, so I've done it with the computer instead. When you read about text mining, one of the catchphrases or the terms people use are tokens. And tokens they can be anything depending on how you view the data, but typically we think of tokens as words. So we're talking about organizing the data so that each word is a unique piece of information. Because in the end, what we're going to want to do is look at how words are used, how often they're used, if they're used together, which words are used together, and that sort of thing. And so we want to be thinking about our data set in terms of words. Another phrase you often see in text mining literature is bag of words. And bag of words just means I got a bag of words and it doesn't matter, which I know to someone in literature that's got to seem like just profane, right? Like we're taking Jane Austen and we're just throwing all those words in a bag and, it doesn't really matter how they're organized or whatever. But that is, statisticians, if nothing else, would kind of confused. So that's a phrase that we use.
Okay. So one of the things that we're going to do, and the text, by the way, I meant to say the script, the R commands, the R codes that I use to do these examples will be available to you on the Digital Scholarship Lab website. And so you'll be able to download that and run everything that I've done. It should be there. So, but what we're going to, one of the things you'll see in there, and I have notes saying what we did, is we're going to reorganize the data so that each word is aligned. So now instead of thinking about it like a book, you've got text and you've got all these lines in the book. Now each word is aligned. So those 12,000 and some thousand lines in one of the books, that's going to now be how tens and tens of thousands. Is that making sense to everybody? So we're thinking in terms of words and how words are organized. And so I printed out the reorganized data. So we go from those lines to each word, that same, basically the same stuff that we looked at before, but now we're looking at it in terms of words. The other thing you'll notice is that the blanks are gone. They're typically of no interest. We don't really care about blanks. You could, and that's certainly something that's beyond the purview of our discussion today, but typically we don't really care that much about the blanks. We just care about the words. So one of the things that, and we're going to have like one slide, I think, maybe two slides where we talk about this, but this is actually where most of your work is going to be, is in cleaning up the data. And so if you think about a text, any text that you're working on, there are going to be lots of words in there that are not of any real material value in terms of understanding the text. Words like the, a, and, to, of, I have those up there, other words like that. An example I can give you is I'm working with some colleagues who have a test anxiety, they're interested in test anxiety, and so they ask students, what does text anxiety feel like? Test anxiety, not text anxiety, test anxiety. I guess some of us have text anxiety too, which is why we like to do text mining, right? Because we're trying to kind of overcome that anxiety. So test anxiety. And so a lot of the students responding would say, test anxiety feels like blah. Well, the words test anxiety are, in this case, stop words, nuisance words, because everybody uses them, but they don't mean anything typically because everybody's talking about test anxiety. So stop words are just nuisance words that we need to excise from the data set. And so we did that. And then again, in the key, or in the script that you'll have access to, you can see where we did that. There are, R has routines that have built-in stop words, like the ones that I showed you, and then you can include other words of interest to you, like I included test and anxiety as stop words to get rid of. But again, this data set is very clean, and in fact, it doesn't take much to clean it, but in real life, data sets that you collect may require lots and lots of cleaning. So that's just a kind of caveat. So one of the first things that we're going to want to look at is, well, what are the most common words? If I get rid of stop words, what are the most common words that might appear in a text? Because that could tell me something about the sorts of subjects, the topics that Jane Austen was interested in. And so this first graph is just a simple bar chart showing us the common words. And without my reading glasses, I'll have to look at this one up here. But Miss Anne, gosh, I do need my reading glasses. That's sad. I actually have them, but so I got the Big Lot reading glasses for like $2. And so I try not to wear them out in public too much because I'm cheap. And they work, but they're not very stylish. So, as you might imagine. But you can see there sort of the most common words. And I limited this to words that appeared at least 600 times in her text. Because obviously, there are certain words that might appear once or twice in this graph. It's massive. Well, why would I want to do this? Well, again, I'm interested in knowing what are the sorts of things that Jane Austen was writing about, or what are the sorts of words that might appear very frequently. In this case, we'll see a lot of it are names. So names, proper names, and we're going to see that as a theme. So this would be a first step. And again, I'm just trying to give you the outline. There's a lot more stuff we can do. But first step, what are the words that appear most often? Let's see if those same common words are different from novel to novel, right? So we've got 6 novels. Let's see if those patterns hold true. Well, this example, I purposely didn't use the remove the stop words because I wanted you to see what happens if I just let all the words in there be in there? And you see, like the first, it's hard to read it, I know, but the very first word is the, and then of. So if I don't get rid of the stop words, this is what I'm left with. I'm going to show you another example where we can get rid of the stop words. But these graphs, again, are just designed to say, if I wanted to look for sort of themes that are common across novels or things that are unique to novels, what are those frequently used words? So this is just saying what I just said. We're going to limit our words down to be a little more selective. Still pretty hard to read, at least for me, but what you'll notice is for each of the novels, essentially names, proper names are the most common words that pop up. I'm obviously not a Jane Austen scholar, so I have no idea if that's important or not. But if I were a Jane Austen scholar, or if this were a data set that I knew more about or felt more comfortable talking about, then I might say, oh, well, that's interesting, or maybe not. But we see here the most frequent words are names, and in particular specific names, right? You can look at those. So word frequencies and getting a sense for what things appear most often, it's going to be something that you really want to look at. And this just says what it just said. One of the very interesting things that you can do with text mining is to classify words or to group words by the sentiments that they are designed to express. And there are several what are called sentiment libraries available. And these are simply classification schemes for words. And they may or may not always be applicable to what you're working on. So one of the first things I would say is, I'm going to talk about them as if, yeah, they absolutely reflect true sentiments, but I also want you to be aware of the fact that they differ. There's several of them that are available and they differ. And that also you can add and delete words from these sentiment dictionaries or sentiment libraries. But the purpose behind them is to help you better organize the text in terms of the sorts of topics that people are talking about. So when I'm talking about sentiment, we could be as simple as positive and negative. So there are sentiment libraries that will just organize words, and these are positive words, and these are negative words. But we can also be more specific, and you see there's a few examples here, joy, anger, and fear, and I think Matthias is going to show us a really cool graph. I'll show you one, but he's going to show us an even cooler one based on these sentiments, right? Yeah, the wheel of emotion. So, but the idea is, this is a way to go beyond just let's count the number of words to let's try to organize those words into sentiments. Again, just to reiterate, you can add words of your own into these dictionaries or delete words. In your area, certain words may be very positive, and you want those in there. And other words that are considered negative, you may not include in your dictionary because in your context they would not be. Okay, so let's just look at positive and negative words. So the first graph we're going to look at is essentially looking at, it breaks each of these novels up into small sections. So if you're looking at kind of the x-axis here, so if I do it up here, like this x-axis going along horizontally, that's essentially breaking the novels up into about 200 segments, and that's just arbitrary. I mean, there's nothing magical about it. Yeah, exactly. Yeah. Thanks, Pat. I should, probably did say it's just a kind of a random sort of thing. But yeah, no, I'm glad you asked me that because it's chronological. So beginning of the novel to the end. And so then on the y-axis, what we have is within each of these little chunks of the book, we have the difference between the number of positive words and the number of negative words. So it'd be like positive minus negative. So before I go further, is that making sense to everybody? And so if you think about it, that can be kind of cool because it's a way for us to see, very, I admit, very gross, very rough way, but a way for us to see sort of the emotive track of the books. So we see that as you go along, say in Sense and Sensibility, it tends to be pretty positive, and then you'll see these negative places, and then in the middle it gets quite negative, right? And then it seems to get positive again, and then it ends on a high note. And in fact, looking at her books, they all, except maybe for Northanger Abbey, the rest of them really end on a high note, right? So they all have pretty big spikes at the end in terms of the positive minus negative.
So this, yeah.
How do you account for when like a positive word is attached like not sad?
Yeah, that's a good question. So what we would do in that case, that's something called, or a way to look at this called bigrams, which is looking at pairs of words together. So yeah, no, that's a great question, Wendy. And so just to make sure everybody heard, Wendy's question was, well, okay, but what if it's like happy is a positive word, but then it's not happy, right? Well, that's not positive. And in that case, if we could look at something, again, called bigrams, where we look at pairs of words. Or you can look at groups of words if you want to. So yeah, great question.
But this problem she's bringing up is not.
It's not addressed here.
Not accountable.
That's right, that's exactly right, that's not accountable. So does that graph make sense to everybody? It's just, again, if you have something that follows a linear trajectory, then this is a useful way maybe to look at it. We can also just do a frequency count of the positive and negative words. And this is a good example of where we might want to change the internal dictionary a little. If you look at the very first negative word, it's miss. And indeed, miss could be a negative word, right? But my guess is, even though I am definitely not a Jane Austen scholar, my guess is that in early 19th century Britain, miss was going to be followed by somebody's name. And so it's definitely not a negative word. It's just it's a way of addressing someone. So we might go back and pull that out. But this is a way, again, if we want to look and see, well, what are those negative words? What do they tend to be? So this is a way to look at that. So now we're developing a picture of what are the words that are used most often. How do the positive and negative words track through the course of the novels? And what are the most common positive and negative words that Jane Austen used? Another way we can look at this is with what's called a word cloud. And word clouds in general, this is a word cloud with the semantic stuff in there, or the sentiment stuff in there. But you can also just look at a general word cloud. And all they are is sort of a graph of the words that occur most commonly. And the larger the word, the more common it appears in the novel. And we had already seen that the word miss appeared a lot, regardless of positive or negative emotion. But also you see good is in there a lot, well, and great. And this is color-coded so that the aqua color is the negative words and the sort of burnt orange is the positive. Again, you can have a word cloud without the emotive or the sentiment part, and then the size of the word just tells you which ones occur most often. I know some folks, and you may be able to speak to this too, Matthias, I know some folks in text mining are not as big a fan of word clouds as others. I've read some people say they can be misleading because you tend to focus on those big words, really important, or not important, but the most common words, and think that they're important. So as you read about text mining, you might find that people say, don't use those. But I find that they can be useful. It's actually how I found out that the word test and anxiety appeared way too often in my colleagues' work because anxiety was always the biggest word in the million. Okay. So what I want to talk about next, and this will be the last sort of big section I talk about, and then Matthias will take over, is we've looked at frequency. And what I'd like to talk about now a little bit is how do words appear in conjunction with one another. So it's one thing to know what are the most common words that Jane Austen used in her novels. But I also want to know, and this gets back kind of, Wendy, to what you were asking, well, what words appear together a lot, right? And so there are a couple of different ways that we can do that. All right, so pairwise word use. So essentially this is just when a word's used together, like exactly together. And so what I did is I just picked pretty much at random the word hope. Seemed to me like a positive word, so I thought, okay, I'll just pick the word hope. And I created a little table here to show what are the words that occur most often with the word hope. And so we can see Elizabeth, Jane, Time, Wickham, and so on. And so a lot of those words are names. And so the question is, well, is that, because they're hoping something, that Elizabeth is going to do something, or Jane's going to do something, or is Jane hoping? It doesn't tell me that. It simply says these are words that are used in conjunction with one another.
Does it take different tenses of words into account?
That's a great question. So the idea of tenses. So when you're doing your data cleaning, you have the choice of doing what's called stemming the word, which basically means you take off what would connote tense, so that hope is just always hope, or you can leave that in. So you could say hoping, hopeful, hopeless, and so on. So that's really a choice you have. Sometimes, and it, depending on the context, those you know, the suffixes and the prefixes might be important, and you might want to keep them, like hopeless is definitely different than hopeful, right? But in other cases, I might not want to do that. So I guess I would say, in this case, we didn't stem, so this is just the word hope. So if I wanted to look at hopeful, I'd have to do it. But yeah, that's a great question, and that's, again, part of that data cleaning that can be so time intense. Yeah. Any other questions up to this point? I feel like I've done a lot of talking.
Can you also have it set so that you figure out what comes before hope?
Yes, and that's you certainly can, Wendy. And again, that would be like the bigram or the trigram. So yeah, if you wanted to see, well, not just how is hope used like this in the text, you know, what other words most frequently occur with it, but also what's always with it, as opposed, you know, yeah, you could definitely do that. Another statistic that some of you will be familiar with and others won't, so I'm going to assume you're not familiar with it, and but I want to talk about for a second, is the correlation coefficient. So we looked at frequencies. One way to say, well, what's used with hope? We just look at the frequency count. Another way is with something called the correlation coefficient. And this is simply a numeric representation of a relationship. It's calculated so that it always ranges between -1 and 1. Values of 0 mean there's no relationship. A value of 1 means two things are perfectly positively related. So if you look at my hand, this would be a graph of a positive relationship, like every time. So let's say, I don't know, if we're talking about like scores on a math test and scores on, say, a physics test, presumably people that are good at math are going to be pretty good at physics too, and so we would expect to see a positive relationship. It might not be 1, but it's going to be a pretty large positive number, say like 0.7, 0.8, something like that. And a negative relationship would mean that as one number gets larger, the other gets smaller. And so, you know, in the context of words, when we see positive correlations, we're saying when one word is used, another word is used. These other words are used with it, and we'll look at examples. In fact, we have some here. Negative correlations would mean, well, when this word is used a lot, another word is not used at all, or is used very little. So that's the correlation coefficient, just another way to think about relationships. So what I did is I asked R to tell me the words that hope is most highly correlated with, and you can see that meet, event, letter, what's the one after live or live, yeah, ready, and dear. So those are the words that are most commonly used with hope in terms of the correlation. So,
Hey, Holmes, how do you determine the proximity there? You know,
that's a good question. Do you know, Matthias, how does it determine the proximity? Because the texts that I've been working with, they're much smaller texts. So here's what I think, Jim, in the case of the novels. Because I know in the case of the stuff I've been working with. In the case of what I'm working with, like the students responding to the test anxiety thing, it's looking at within an individual student. Yeah. So my guess is it's looking here within the novels.
Remember, you have to set, like in this case, we have 6 books. So it's looking in between those 6 books, right? So that's what it uses as a comparison.
so you could theoretically break it down into chapters or things like that. So.
That's what I was going to say, and that's what I've been doing.
You could break it down into
I've
chapters.
seen people talk about doing it at paragraph level.
Yeah,
I mean, it just
absolutely.
depends on what you want to know.
Yeah, that's right. And I'm really glad you guys asked that question, because yeah, exactly. You can break it down into whatever unit of analysis you want, whether in this case it's the whole book or paragraphs, sentences.
In the slide before, you had that names most often appear.
Yeah.
So how come the names are not?
Yeah, that's a good question. I mean, it's, let me think about that for a second. So this is the frequency count, and this would be the correlation. And so, yeah, I think it's, that's a good question, Wendy. I would actually have to investigate the data more. You shouldn't be asking me that question. All right? I'm supposed to know what I'm talking about. No, that's a good question, and I don't know. I mean, I know there's a reason, but I can't. Lisa?
Would it happen to be that those names also occur without the word hope?
Yeah.
And so does that take into account the correlation, how frequently these things occur without each other?
No, so the way it's calculated is just within the books, it's going to say, here's the count of hope, and here's the count of something else. And then it's going to calculate, so what you're saying is the correlation. Yeah, it should. I mean, there is a good reason, Wendy, and I don't know, and that's a good, yeah.
I would assume it's because different books have different characters.
Yeah, that could be, that sounds good to me.
So, I'm sorry, but I'm not understanding like what this signifies. So when it says that hope and need are strongly correlated, what does that mean?
So what that means is when the word hope appears, then meat is the most, no, let me rephrase that. The frequency count for hope, the number of times that hope appears, is correlated with the number of times that meat appears, so that when hope occurs a lot, meat occurs a lot. When
It doesn't mean that they appear near each other.
not necessarily, no. But I think, no, but it's,
That's actually, that's the reason why the correlation is different.
but it,
Hope in the Bible.
Yeah, no, I understand the correlation.
but is the correlation calculated as a diagram? Or is it by degree?
I think it's by the text, that's why it's by the.
Yeah, but that's why I was thinking, that's why Wendy's question still befuddles me, because that should. There we go.
Corpus or the null?
Yeah, we could have definitely done that, yeah, we didn't in
It's the
this
corpus
case.
of 6.
Yeah, I mean, those are all good explanations, and probably one of them is right, but I don't. Yeah. No, that's a good question, Wendy.
Or none of them.
Yeah. What's that?
Or none of them.
Yeah, or none of them work. That's right. Who knows? The sad truth is, actually, as a statistician, I will come clear, we just make all this up, right? So we have to be employed, and so we figure, well, if we just throw enough numbers at people, they're gonna say, well, okay, I guess if it's numbers, it must be right? So that's the truth. I'm sorry, I'm leaving now. No, that's a good question, and I actually don't.
Like
That would mean then that the correlation is useful for comparing the novel against the ordinary. So if hope and need are strongly correlated in Pride and Prejudice,
Right.
not in Sense and Sensibility.
That's right.
Potentially revealing.
That would be.
But
that
they
would
don't
be-
actually say anything about those words being used in tandem.
No, just the frequency within the novels, yeah.
No, and you could do, and maybe not in this tool, but other tools, you can do a keyword in context, where it'll give you the
Yep.
6 words before and after a word.
You can definitely do
And
that.
so you could take a word like hope or love or whatever you want.
Yeah.
And you can see that. I don't know if art does that, but.
It does,
Yeah.
it does. In fact, it has the capability, you can do that sort of thing with sentences. So you can say, you can leave the period in there and use the period as an obvious indicator of the end of one sentence and the start of another one. And then look to see, as you said, Doug, what appears, whether 6 words around it or just in the same sentence, however you want to do it, yeah. Yeah, that's a good, yeah.
So this pairwise word use, are
Those are frequencies,
is this when like the word hope appears before Elizabeth, or is this the same thing where it's just frequency?
just frequencies, yeah. So it's just Hope and Elizabeth appear. So with the books, I mean, that's the downside maybe of using the books, because they're so massive that the context is not as clear. But yeah, it's just, if Hope and Elizabeth appear 39 times, yeah.
In terms of filler words,
Yeah.
would you be able to eliminate names?
Yep,
Okay.
absolutely. So if you decided names were not germane, you
Uh-huh.
pull them out.
So not like a specific name, but if you could say, hey, anything that looks like it's a name, or would you have to specify
I
the
think you
name?
have to specify. I
Okay.
don't think that, as far as I know, there's not a function.
That's use a name dictionary and then.
Yeah.
You could do that.
Yeah, you could. I mean, the easiest thing would probably be just to take out the name, it's like individual tree.
Right. And it doesn't recognize caps.
This is because of time period study, a historian, I'm just gonna ask one of my colleagues who, but do you know of specific sort of, say, sentiment analysis, libraries that are kind of per period, time period? Because I do early modern English,
Yeah,
history,
and so the sentiments are
some of
gonna
those,
be,
they're gonna be a little different.
yeah, a lot, in fact, a lot.
I mean, I was thinking of how I can make one of these libraries, or I just don't know if anybody knows if there's one.
That would be, no, I mean, that would be the sort of thing that my guess is, digital scholars in.
Yeah, I have people I'm gonna ask, but.
Yeah, no, not that I'm aware of. But I also would not be shocked. I mean, that's one of the neat things about R is it does allow for people to create those kinds of things. So it wouldn't shock me if that was available.
Yeah.
But I'm not.
But there's a lot of early modern.
Yeah.
So it could be the first one.
Yeah.
Oh,
you
yeah.
could do it.
It's gonna be a lot of work.
So then I picked the word, I picked the name Darcy, and I just said, well, okay, what's correlated with that? So again, you can see just words that are correlated with Darcy. For no real reason other than it's the name that I remember from the book. The last thing I want to show you, and then I'm going to turn things over to Matthias, are what's called correlation networks. And so these are ways to visualize the correlations maybe a little better than what we just looked at. And so essentially, I'll just show you a picture. So this is, these are correlation networks, or sort of a graph of words that appear with correlations of 0.2 or higher. And those words are connected by lines. And so you can kind of get an idea of, well, what are the interrelationships among the various words in the text? Not just pairwise, in other words, this word with this word with that word, but kind of a bigger pattern of how words are used. And I picked correlation of 0.2 is considered kind of small if you're not familiar with correlations, so those would be fairly weak relationships. If I increase that threshold to 0.4, then you see that a lot of the those go away. So 0.2, I've got lots of little networks, lots of little relationships between pairs of words like aunt and uncle appear there, proud and pride, half an hour. And then if you go to 0.4, well, now you can see there's very few pairs of words that have correlations of 0.4 or higher. And so that just gives you an idea about, again, 0.4 would be considered kind of a moderate size, like medium. It's not massive, but it's not teeny tiny. 0.2 wouldn't be teeny tiny, but it would be on the smaller end of stuff. So just a way for you, again, to visualize what's going on. So I'm going to turn stuff over to Matthias. The last thing I would say is the next step in this would be like a course 2, which might be, or which would be clustering. So we can start clustering the books, grouping the books together, or any other text you have. And that would be based on these correlations. So imagine taking those networks and then doing it by book and then seeing if you can come up with patterns in of books that seem to have similar kinds of correlation patterns. So, great. So I'll turn it over to Matthias.
Thank you.
Yeah. So I'm going to sit and I'm going to block the screen.
All right. Is this on? Is this coming through? Mic check. I'm just gonna sit here because I'm gonna be running actual R code from now on. As Holmes said, the script will be available to you, so you don't have to. I mean, some people internally freak out when they see R code, which is completely understandable. I will go as slow as possible, but as fast as necessary to get through most of the material. But feel free to ask questions at any point. We sometimes, we develop tunnel vision because everything is very obvious, and then we forget that to most people it's less than obvious. So what we're going to do is we're going to first, this is kind of catchy, of course. I like to give this number because now in comparison to the 17,000 lines in the Jane Austen novels, they seem vanishingly small compared to 500 million tweets a day. To put this in perspective, that's over 20,000 copies of Tolstoy's War and Peace, and it would take 77 years to read this, right? So this is the amount of tweets that's produced every day, which makes it. I like to use this number because it puts things in perspective and it shows you that without computational methods, there's no way to make heads or tail of this stuff, right? What we're going to do is we're going to actually live collect data because while a pre-made data set is very nice to practice, and I encourage you to actually do practice because it takes some ingraining before it clicks. I assume that 95% of your data will not be clean, and this is going to take you through the steps that are necessary to get you from a very messy tweet to some of the visualizations that Holmes just did. I'm also going to extend the sentiment analysis by Plutchik's wheel of emotions, because sometimes positive and negative is just not enough, right? And you want to have a little more fine-grained analysis, and one of the built-in sentiment lexicons in the tidy text package is actually able to provide those emotions. Let's go to answer your question. It's fairly easy actually to write your own sentiment lexicon, right? Because the built-in one is actually fairly small.
Yeah.
Or one of them is actually fairly small, and sometimes nothing will be available, right? But let's say you want to do movie analysis, right? Then you can use like awesome, great, and super duper as positive words, and shit, crap, and whatever as negative words, right? I mean, because that's the stuff you're going to find online. So, and that will already give you a pretty good overview of what the underlying sentiments are. Okay, so. Don't freak out now. Those of you who are staying later, we can go over the stuff in a little more detail. Otherwise, this is what I use. This is RStudio. This is the closest thing to a graphical user interface you get with R. And it's neat because you get to write all your code here, and then this environment that's empty, that's, by the way, this is on purpose so you can see that we're really starting with a clean slate. There's nothing, no single piece of data, no datum is available here. The current version is somewhat to lean on. All the R versions are based on characters from what's the Charlie and the little bird. I forget now. Charlie Brown. Yeah. With the little bird. Right? So also, if you've ever, Woodstock, exactly. If you ever wanted to do Twitter analysis, you're in luck, because the package we're using was actually not the one I used for my dissertation. This just came out in November 2017, and it makes things a lot easier. It already, and I'll show you what it looks like. So the first thing you're going to do essentially is to load your packages, right? So this is just setting up your R for analysis to actually able to do what you want to do. Then this next thing, you won't have this because those are my private access keys for the Twitter thing. You will have different ones, hopefully. So don't write those down. Sometimes it logs you out automatically. Unfortunately, I also turned off my phone because I got a call earlier. So sometimes you have a little hold up, right? But this is what it looks like. Show and tell. You will verify that this is you, and then once this is done, we go back to R essentially, and the package is set up to collect tweets. Okay. If it didn't have set up two-factor authentication, we would already be in. But we want to be as secure as possible these days. So the next step, I can already explain this. Now this is the function search tweets. This is the function that actually then gets you the tweets, right? And you could specify whatever you want here. This is hashtag coffee. I chose this because everybody runs on coffee except for Wendy. And the number is the number of tweets we want to collect. and then include retweets. We don't want retweets, right? Sometimes you might want retweets, but let's say you want original user data, you want to exclude retweets because that's just what everybody, that's just a copy of somebody else's tweet, essentially, right? So let's see. We've got a text. Luckily, this thing works really reliably. So. Okay, see, now we're done. We're ready to collect. So I'm going to set this up because this takes a while. And now it says searching for tweets, and depending on the amount, you can also put 100,000, and that's it. Now, what it accesses on Twitter is the public. It's called the public API. It's an application programming interface, and we only have access to, I think, they have certain cutoffs, and you only get like up to 1 million tweets for that period. That's just the way it is. Some companies, they buy what's called a fire hose access. It's actually, you have to pay for it, and they get access to all the tweets that were written ever. The National Archives actually have all the tweets starting in 2006, but they don't have a search engine that's good enough to search them all. So yeah, so this is just searching away. The other thing I put in here, sometimes you want to search for a particular user, right? Maybe you're interested in only one user's timeline, essentially. Then you would use a different function. The timeout, it stops after 30 seconds. The good thing is with this new package that is a lot easier to handle, you can actually set this up. If you have a designated computer, you can set this up so it will collect tweets for an entire week for you. Right? I mean, yeah, Doug?
How about if you want to look for a certain class of user, like an institution, or libraries, or?
Yeah, I mean, if they have a Twitter account, you can
I mean, like, but just as a group, all the libraries.
Yeah. You could. Well, you would have to look up what libraries or what accounts you're interested in.
You have to have their account.
Yeah. And then you could essentially here. You would then.
Yeah, I collected all the special collections libraries.
Okay. Yeah.
And it can be a little involved if you're getting down to that level as opposed to the libraries, but yeah, it can be done. So.
Yes. Yeah. So.
It was actually not that many. It was just several hundred in the United States.
Yeah.
You can also say the geographic boundaries.
Yes. Mm-hmm. Okay, so sure enough, our collection is done. We've got almost 10,000. This sometimes varies a little bit because of the cutoffs that you have built in, right? So then if you really need 10,000, then you specify 11,000 or something. This is what it looks like. This is fairly big, so it's not going to take a little bit. Yes. So you get the status ID. That's the tweet ID. You get a created at down to the second. You get a user ID, which can sometimes be interesting because if it's a specific political topic, right? There might be users who tweet a lot about it, and then you want individual users, and not like So then you get the screen names, and then you get the actual tweets, and you can already see you have #coffee, #coffeelover. Then you have a link in there, and all of this messy stuff. You have an ad mention in there. What else is there? Yeah, then you have emojis, right? And all of this stuff, I mean, depending on what you want to do, all of this stuff has to go first, depending on, like I said, depending on what you want to do. And you can give to the source, so you could break it up by source, and then there's a ton of other information that you get if it's a retweet. And this,
I was going to say, the source is really interesting because I was reading an article about a study someone did, and right now it escapes me, but of when their tweets were coming from real Donald Trump on his Android versus something else, another device, and then doing the textual analysis of those tweets, so you could get a sense of who was actually doing the authoring of those tweets. And you could see which ones were his and which ones were not, somebody else's. So, it's really cool. I did it with the NRA versus gun violence, one of the gun violence organizations. You really tell them.
This new package also has a big advantage over the old one. It automatically extracts all the hashtags, right? Sometimes you just want to look at the hashtags and then you have to do that yourself. This package now puts them in a nice little list. Instagram, for example, doesn't have a very good API, which means, but a lot of people, they have a Twitter account and an Instagram account, so it automatically gets posted on Twitter. That means if you're interested in their Instagram account, you just collect the tweets and then filter out all the stuff that came from Instagram, and then you have by proxy access to Instagram data, essentially. Any questions so far? Yes?
Can you include or eliminate images or GIFs?
Yes. I mean, the whatever you get back as data is going to tell you if there's an image, and it's going to give you the URL to the image. But it doesn't give you the actual image.
Right. But you can't like search for only things that people have said versus images they've shared.
I've never tried that. I'm sure there's a way you could do it, but so far it doesn't give you. It only gives you the image URLs, right? So and everything else you would have to try. So what we're going to do, we're just going to select only when it was created, the user ID, the text, and the language out of the 42 variables. See, it's still the same number of tweets, but it's out now only for features that we're essentially looking at. The next thing you want to do is you want to filter out only the English tweets, right? Unless, of course, you're interested in a different language. But for our purposes, we're just going to filter out the English tweets, and we're going to create a participant ID, right? So that's been created down here with this function up here. I always like to be a little more precise, so luckily there's a good package, it's called CLDR, that uses Google Chrome's language detection, and then you go over the whole thing again essentially and filter again to see if there are any non-English tweets left, and then you see now our number is actually down to 7,800 roughly. I put this in yesterday actually as a tangent because I stumbled upon a package that I had installed. It's called Gender. It's an automated gender detection package based on name data from the Social Security Administration. So depending on what you're doing, right? If you, let's say you have a video, a movie script, and the lines or the parts start with the character's name, then you could automatically have R tag it for gender. And this is based, I think the data goes back until, up until 2012, it goes back until, I think, 1910 maybe.
Is it just coding based on name? So that's how it's assessing gender, no other?
This is a very simple, a simple process. So if you wanted to do it for tweets, then you would essentially use the screen name to detect gender, right?
Okay.
But as soon as you have a sentence, then you can't be sure if somebody's talking about Tom or Tom actually uttered the sentence, right? So
yeah.
So is this looking at their handle, their @, or is it looking at
yes.
their name on their profile?
You could decide that, right? But if it's then again, that's sent towards somebody. That's not the person who uttered the tweet. So you would have to look at the screen name to be sure that that's actually where the tweet is coming from, and that is diluted these days because most Twitter users don't use their actual names as their screen names, right? So that probably would break our number in half, or maybe even lower. Yeah.
I don't know one off the top of my head, but I know there are kind of packages that will they can kind of analyze text and written things and kind of determine or make a guess at gender based on the writing side.
Yes. Yeah. I mean, there are. I mean, that's what I said. This is very, very simplistic. There are gender prediction mechanisms there of 99% accurate, and then you just put in text, right? I haven't found one yet that's available for R, right? So then the next thing we're going to do is, now this is where we're essentially on the way to getting the data cleaned, such that we can then plot them like Homestead. I'm going to quickly show you this function. this function essentially first, for example, removes the URLs, right? Because when you do textual analysis, you don't want your data diluted or skewed by HTTPS all the time. It also removes retweets, should there still be any left. It removes line breaks, it removes hashtags that have been left in there. It removes the ellipsis symbol. That was something that I stumbled across in my dissertation. I was like, why does this keep popping up? And it's because it wasn't 3 distinct periods, it was the emoji for the ellipsis symbol. And that's just something you have to figure out by trial and error sometimes. What is also interesting? Yeah, so this line down here, for example, that removes any and all emojis, right? Of course, you would have to, if you wanted to look at emojis specifically, then you would have to use a different function to extract the emojis, right? So this is cleaning away, and when we're done with this, we're actually going to have not a by tweet representation anymore. We're going to have a by word representation, and now we're getting the hot zone, and you can see 7,800 tweets became over 133,000 rows. Right. So those numbers now show you that you can't possibly hand count any of this stuff anymore. Now we're gonna remove the stop words Holmes talked about. And you can already see in the output down here what's the most frequent word? Not surprisingly, coffee, right? Yeah. So I'm gonna put this on a plot for you. So this is still very, this is a lot, right? And the reason why this looks like that is because I specified anything bigger than 100, but since the smallest one is 300, let's try that out and see what happens. And see if this gets a little cleaner. So now the lowest one has to be less than 100, right? Now what is a problem with this graph? A very obvious problem. Coffee is completely distorting what's actually going on, right? So I'm gonna skip the word cloud thing because all that would happen is essentially that I'm gonna show you. I'm gonna show you just for fun. Yeah, I mean, you know, what the heck. While we're at it, so this sometimes takes a little bit, yeah, I mean, and it's not informative at all because everything else falls in the background, right? Actually, stop this. But sometimes this crashes stuff.
Oh,
yeah, when you stop it, yeah. So if you can already see that if you have a data set that's over 100,000 words, right? It still takes some processing. Okay, so imagine you collect tweets for an entire week. You're going to end up with, I don't know, 10 million tweets. You run this function, and you will have time to get coffee. Yeah, I mean, and this is sometimes we forget this sometimes, right? And it's like, oh yeah, I'm just going to run this analysis, and then you're waiting a half hour for the function to finish. Luckily, I once wrote a little thing that you can actually write something that lets an alarm go off on your computer when it's done, or that opens. I once wrote a thing that opened a YouTube video to a funny cat video. Once the function is, yeah. Because otherwise you're just going to look at your screen the entire time, waiting for it to be done. Okay, now we get into the nitty-gritty because we have to filter out coffee, right? And this is what now we're going to do exactly what Holmes was talking about. We're going to filter out coffee, a word that was distorting our analysis. Maybe use 300.
I had it set on.
I had it set on 100.
Oh, okay. Yeah.
But now you can see that the picture looks a lot clearer, right? And then you can also see you can color code it, so you also have a visual representation of what's less frequent, what's more frequent. And all of a sudden, once we remove that high frequency word, you get mug is the most frequent word. Which if we did a bigram analysis, that would lead us to believe that coffee mug is probably very high up on the list, right? Morning, understandably, is very high up on the list. Coffee lover, that probably comes from one of the hashtags that was included, right? Or hashtag coffee time, probably. So, could do I'm not going to do the other word cloud because that's going to, the function is in there, so if you want to run it with the new thing, that's possible. But I want to get ahead and talk about sentiments, right? Now, Jane Austener that's literature, or that's it's also very old, right? Coffee, we would expect, it's not a very loaded topic, right? I'm going to give you, when we did a test, Steph was there, Doug was there, and I think Jim was also there. When we did a test with a very politically loaded topic, a certain president's name would pop up all the time, but the sentiment dictionary counted that as something positive, right? Because playing cards, Trump is definitely something positive. So, it's an important realization, because as Holmes was saying, just because you're using the computer to run your analysis doesn't mean that you can blindly trust it. You always have to gear this towards the context and towards your hypothesis or research question, right? So in this context, you definitely would have to change the sentiment dictionary and include it either as neutral or as negative, right? Okay, so this is one of the plots that Holmes was also showing you. Now this makes sense, right? Coffee is removed. Cold is one of the top negative words, especially since it's March and it snowed an inch yesterday, right? So that's probably a remnant of that. Positive, of course, love, win, free coffee, ready, happy, perfect. Negative, funny, hard, break. I assume that break is here in the context of the break is over, maybe. Wendy? Don't ask me anything I can't answer.
So cold is on the negative side because it's listed as one of the negative words.
Yes.
Okay.
Yeah.
But it could be like cold brew coffee.
Right. It could be, yeah,
okay.
absolutely.
Okay.
Yes.
So you may decide, I want to make that, you can take it out or.
So, and of course, we can't this has to be clear, we can only scratch the surface here of what's possible, right? This is an iterative process and also one that's recursive in the sense that you do some analysis, you realize something, and then you go back, right? In this case, you then would look into bigrams and trigrams, and you would start again into your sentiment analysis and see if this still holds up. Okay, so this is another fun thing that I thought of. I'm not going to do the correlation analysis, simply because with tweets, remember here in Holmes's case, or the Jane Austener package case, we did it by book, right? For tweets, this is somewhat more difficult. Not because it's computationally difficult, but it's because it's difficult because you have to decide what is your smallest, essentially what's the common denominator, right? Do you want to break it down by hour? Do you want to break it down by day or by week? Or do you want to say, I want to compare weekdays and weekend days, right? So this is something that you would have to decide looking into this stuff, right? So maybe you want to look into is hope higher correlated with, or is coffee mug higher correlated on the weekend compared to the week, right? But that's something that you would have to decide to begin with. So what I'm doing is I'm essentially extracting the hour, which is, if you remember, we got the created at. That's one of the variables we got, and with the function in R, you can extract the hour during which the tweet was made. And then we're going to look at the tweet polarity. You can also call it sentiment. This is what Holmes was showing, where you had the diverging polarities throughout the books, right? This is going to happen now for the tweets. So in this case, we have only positive tweets, right? They're coded in green. If you look at the bottom, you see 0 and a blue line. Now that would be our 0 line, right? So if there were any negative tweets in there that are predominantly negative, then it would drop below 0 and will be red. Now, it's important to mention that this is how the calculation was done, that of course you could base a tweet, let's say, on one single word, and you say that one single word is negative, right? The question is, would that make the entire tweet negative, right? And in this case, the way we calculated it, and the way the authors of text mining suggest, is so you get the sentiment for every word. That's what the sentiment lexicons do, right? So you get the sentiment score, essentially, for every word, and then you subtract the negative from the positive, right? And the remainder, if that's positive, then the entire tweet is positive. If that dips below 0, then you can assume that the tweet is predominantly negative. Now there's a little bit of math. Is that some? I see some puzzle faces. Yes.
So how do you deal with sarcasm?
I mean, we could do an entire other workshop on that. But this is a very good question, and sarcasm still to this day is computationally very, very difficult to detect. So I was talking earlier about the gender prediction algorithms that are like 99% accurate. Sarcasm is, I think computers are too dumb. And I think it's for a program, it's very, very difficult to program that context into the tweet or into the function, right? It's easy when you have a tweet and you search for the hashtag sarcasm. Then you know predominantly tweets that you get are going to be sarcastic comments, right? But let's say you want to detect sarcasm in a movie script, or in, I actually found out that they have the scripts for a ton of TV shows available, that opens tremendous amounts of alleys for textual research, because you can look into how is genders distributed, how are, I don't know, different characters distributed, what's the language they use, is one character more negative than the other character, but you can't, I wouldn't know, it's very difficult to detect sarcasm in a movie script, right? That's just something, because it's so context dependent. And what is important for sarcasm? Paralinguistic cues that you don't get from text, right? You have to see, because that's the definition of sarcasm, is that you have to see the person's face to hear how they say it, right? Or you have to say hashtag sarcasm, right? Which some people do that now.
Lisa, did you have a question?
I have a question about once it's labeled, so once you subtract the negative from the positive, once a tweet is labeled in a certain way. So I could imagine you can also do this with other types of text. Is it possible then to create a new data column with the official label, it's positive or negative?
Yeah.
So then you could run that column against like rating scales or other pieces of data you collect.
Absolutely. Yeah.
That's super
And then
cool.
remember here, this plot is actually, it's not done by tweet, it's done by hour, right? So it looks at all the positive words for 5 o'clock in the morning, it looks at all the negative words for 5 o'clock in the morning, and then they're subtracted, and what's the remainder, you see if it's predominantly positive or negative.
But you could adjust your unit.
Apparently, Pat, I mean, who's up at 5 o'clock? But you see, and we've run this sample, or this example with hashtag coffee. I've run this now 5 times, and what's consistent is when the positive spikes. And that's when people get up, and then it's close to, it's throughout the day, and it drops off because then it gets close to the evening and people stop drinking coffee. So people also stop tweeting about coffee, right? What's the first thing somebody does who tweets hashtag coffee lover? That's probably going to be during the morning hours. And that's what we mean when you say you have to factor in context, right? It would be weird if the spike was at like 12 midnight. Which could be true if you were like looking at tweets in Chicago during Lollapalooza, right? I mean, you have to. This is a holistic analysis.
So Lisa, just getting real quick back to your question. So yeah, what you could do, like in the case, I was just thinking about it, in the case where I was looking at how students talk about test anxiety, you could classify each of those responses then as positive or negative based upon this thing. So instead of hour, those might be the individual people.
Students.
Exactly.
Yes,
Yeah.
that would be really interesting. For, yeah. And then you could classify even more in depth rather than just positive and negative into all the sentiments.
Yeah, we're gonna get to it.
Okay,
Yeah.
sorry.
Yeah, you're fine.
You're probably going there, but can you break it down by geographic area? So like both New York and Las Vegas claim to be 24-hour cities. Do they have the same copy data?
You could. I mean, there are several ways to do it. The easiest way is to search for hashtag coffee, hashtag NYC, and hashtag LA. But this new package also has a way of specifying geographic location. Your sample is going to be very limited because in 2014, geotag tweets that became opt-in. When Twitter started in 2006, that was just the default setting was that when you tweeted, it was geotagged with the geographic location. They switched that in 2014, so now I think in the US it's like 1 or 2% of tweets are only geotagged. Right? So that, I mean, you could still do it. You could still select or collect a big sample and then look at all the tweets you have geo information for and plot those and say, we can probably extrapolate that is a pattern or an underlying pattern, right? We're going to look now at one of those comparison files that Holmes showed you. Sometimes they print the labels and sometimes they don't or only half, and we double check. It's an inherent problem with the package, apparently, with the Word file package. I'm sure they're aware of it. I think if you just have to run the function a couple of times and then it works at some point. Yeah, see, so you can see like the top of the label, it doesn't show on the screen.
Yeah, I would say one thing this demonstrates too is, and Matthias had talked about it a little bit before, but that is, if you have big data sets, one thing to be ready for is patience, right? Because a lot of times we're used to working with Excel or Word or something where things are more or less instantaneous. But when you get big data sets like this, even if you have a really good computer like his, it still can just take a while. And I think that's, so you can just say, I'm gonna let this run and I'll come back in a half hour and see if it's done, or an hour, or overnight, or 3 days.
Yeah. Yeah.
So how do you get your data into this platform? So for example, if your data is in a Word, you know, if you get focus groups into Word doc or it's an Excel file, how do you?
While this running, okay, there's several ways. There is a Qualtrics package for R. It goes to an API that you have to get a key for, which call state has. Then you could essentially, any questionnaire that was answered, you could directly import that into R, right? That's one way. If you have textual data, then there's packages that read in Word documents or PDF documents, right? They're very accurate. I'm actually doing work for the DSL, and they read in stuff one-to-one. Yeah, because they're not like, if you think back when people scanned documents with like an OEM software or whatever, they always had a certain margin of error that you had to hand correct. That would be insane if you wanted to do that here, right? So they read the document in as is.
If you do find yourself in a situation with a lot of data, we do have some things we'd like to explore here with some computer cluster kind of high-speed stuff that's available that we could help get you in contact with. So if you have something that is going to take a lot of processing power, you don't have to just use your laptop.
Yeah, like Holmes said, companies, they run like parallel computer clusters to process this stuff, right? Or they have an office with like 5, and then 1 or 2 are just running essentially analyses. Okay, so let's get into Qualtrics' wheel of emotions and break this down further, going beyond positive and negative. The lexicon that's used, that also comes with the title text package, is MRC. That has all the words labeled by either positive or negative, or by the 8 Qualtrics emotions. That means before you do the analysis, you actually have to get rid of the positive and negative, because that would then water down your analysis. So that's what I'm doing here. And then we can already plot the sentiment for our teams. And you can see it's broken down by joy, anticipation, trust, sadness, anger, surprise, fear, disgust. Yeah. Well, we would expect disgust to be fairly low when it's about coffee, right? I mean, Wendy probably contributed that disgust. Yeah. So one other thing to keep in mind that Holmes also mentioned is that you see that the most frequent one is joy, with a little over 4,000 mentions, right? Of course, that's not in alignment with the vast number of words we have overall, because it can only be compared to what's in the sentiment lexicon. That's just by its nature, that's going to decrease the amount of words that are going to be analyzed, right? It doesn't change the fact that that's the MO that everybody's using, and that's what we have right now. Okay, so unless you build a very, very extensive sentiment lexicon, that's what we're left with. However, the ones that are in there, they're commonly used by people, right? And the people who build them, psychologists and linguists, they also validated them, right? So And when we communicate, we use like 500 words, right? And the same is true for sentiments, probably, right? By extrapolation. So the amount of words that people use every day to talk about sentiments can probably stuff into a 100-word sentiment lexicon. Is that all encompassing? No. But it's probably enough to get a good representation of the sentiment that's going on.
I've got a question for you.
Yes.
Or maybe more of a request for both of you. You've spoken a lot about how this is, it's a great way to generalize these ideas of data, but you also have to put it into context. So obviously, and you've mentioned that this isn't the answer. It's not like you plug in your scholarship and it gives you all these answers. So could you talk a little bit, maybe to the group about what do you do with this information after you have it? Where in the process of digital scholarship and in terms of people using this with their own data, where are they in that process of plugging this in and how does it benefit them?
Yeah, sure. So that's a great question. And I would see this as part of the larger research process. So getting back actually to Lisa's question, and I can tell you just my experience with, again, working with different researchers. So if I'm looking at the focus group transcripts and college students are talking about a specific topic, let's say race, then I can identify the individual student, and if I have identifying information about them, then I can take the results of this, so I can look at how frequently they use joy, sadness, disgust, whatever, and then look and see whether that is related either just with frequency tables or correlations or something like that, to their ethnicity, to their gender, to their year in school, and so on. So that would be one example. So with the test anxiety stuff, we have not only what students say test anxiety feels like, so my stomach is sick, I'm sweaty, and all this kind of stuff. And that by itself helped those scholars to understand better how students are experiencing it, because there's tons of surveys to measure test anxiety. And so then what we did is we essentially classified students based on whether they had physical response to test anxiety or whether it was more like worry, but not necessarily physical. And then we went back and said, are there differences in their scores on these surveys, these test anxiety inventories? And we found, yeah, there actually are, that kids who have certain physical responses have higher anxiety scores. And so that's where I would see it as part of this bigger picture of understanding.
Sure. So almost casting this big net to generate more questions that you can dig down deeper into is one way of looking at the benefit of this.
So Doug and then Lisa, I think Doug.
I just wonder, so if you're using this stuff like you did in your dissertation and thinking about maybe you've already published something on it or in the process of that, what's your responsibility then as the researcher to make this data set available for others to see, to check your work,
Well, the thing with Twitter in particular, we have a problem. Twitter doesn't want you to share collected data. People did that in the beginning, and then people, when Twitter started cracking down on that, because there's money involved, there's companies who sell Twitter data slides from 2006 to 2010 with those keywords. That's not very, user friendly, but that's what Twitter wants because there's so much money involved. But which also means that now people are not allowed to share their data sets anymore. Imagine somebody collected just a random tweet sample for an entire year, right? And he could share that, then people could do all kinds of analyses with it. And you could then do really chronological analysis of how topics changed or how sentiments changed about a certain topic throughout an entire year. So if you want to do, unfortunately with Twitter, if you want to do analysis at that level, then you have to quickly start collecting your own data. Or you have to buy it, right? If you can get a really good grant, then you might be able to buy data for an entire year.
So if you're collecting, what is the window that they allow you to collect? You can't do historical stuff, right? Or do they? Does the API allow you to go back, or do you have to buy that from somebody who's curated that?
That depends. If you now our data, let me actually check if it is. Yeah. think I broke it down by. Oh yeah, so now we have roughly 10,000 tweets, right? And they stretch about 3 days. They go back until the 20th. It will vastly depend on what you collect. Twitter allows you for, let's say you wanted to collect tweets about me, right? And you would have my Twitter handle. You would only be able to get the last 3,200 tweets. That's where they cut off if you collect a specific individual's tweets.
So it doesn't matter over what amount of time. Because
depending on the activity, and I have this in my dissertation, over some people tweet 50 tweets spread out over like 5 years. That means you get all their 50 tweets reaching back 5 years, but that's it, right? And another person tweets, I don't know, every 100 times a day, and then their tweets will only reach back maybe half a year, right? I would say for a more general analysis, it's always better to actually get a randomized sample, and then let's say, I don't know, it's always good during like election cycles, because then you can just say, I know that primaries are going to be in this time period, so I'm going to start collecting tweets a day before and up until 2 weeks after, and then you have a fairly good representative data set for this particular period.
But I can't say I want to get the tweets from 4 years ago. Or
you can, but then you have to pay.
That's what it is. Okay.
So Lisa, I think you had a question?
So with the physical test anxiety results, did you have to create your own, because it's not typical sentiments, right?
Right.
So then you created sort of a similar catalog for another type of thing. So if we wanted to code on different principles of design thinking or whatever it is, then we create something that's analogous to a sentiment catalog.
Right.
So all the words that, if I was curious about collaboration and designing, so I would create all my synonyms.
Yeah, so right, so you might start with an existing sentiment dictionary, and then you can see the words that are in there that's transparent, and then you can pull out words that don't apply in your case and add words in. And then use that, or you could take them all out and start your own. Yeah, you can absolutely do that.
Because it's not always positive or negative. It's like,
sure.
The difference between stomach aches and worry is not, they're all in one field.
Right, and so
it's so interesting. Okay, I get it.
Yeah.
The word bad is often good.
Yeah.
I think we're going to start the break now, because I know some of you have to get going. We've got your emails, you've got ours, so stay in touch, and we'd be happy to talk more about what you guys are doing. So thanks for coming.
I also left my card
yes.
on the table, so if you are interested, just with what Jim said about project management consultation for a digital project, anything like that, please feel free to take one and reach out.
There's also cookies, water, coffee, so you're welcome to hang out for a few minutes. And,
tea, we have tea.
Tea as well, yeah, and help yourself to any of that. And a few of you I know have brought data, so in a few minutes we'll reconvene to do more one-on-one kind of stuff.
I did.